All
Are you
right.
good?
Yeah, we're good. All
All
right.
right, this is our second evaluation, group 29. So for question one, this was about a manager wanting to change the system to story points from to track time rather than the quality of the work. And this has a couple issues with it. And then the main issue is misunderstanding the point that story points are used for, and is to measure the complexity of a task and the effort that it will require to solve said task, not to measure the time that it will take to solve that. And then the second issue is developer burnout. And then it's basically because this look at the work prioritizes the quantity over the quality, and then this is just going to add more stress to the developers as more is expected of them, and this could also decrease the quality of their work. And then the third issue is reduced team and developer autonomy, and this view of quantity over quality will take away their control to make realistic estimates for the amount of time that it will take to get a task done that is given to them. And then for the solutions, there are many solutions to this, and then one of them is to just let the teams make the windows that they can solve the tasks in. And then the most important one is to not correlate story points with time, and because user stories and story points are purely for the complexity. And then focus on the values, so the quality of the work over the quantity, and to get direct feedback from your team and the developer employees, I guess. All right, question two.
So question two asked about the architectural style that Tor uses, and we answered that it uses the peer-to-peer style. The peer-to-peer style doesn't have any distinction between the client and the server. They both act together. And since the web traffic in the Tor website is redirected through a series of nodes, it fits the description for the peer-to-peer style. This style is effective for anonymous communication because since there are so many nodes acting on the server, it's unclear who's doing what. And the lack of a centralized server makes it very difficult to track and monitor any actions. And for question three, they asked why programming languages like Go and Rust choose a composition approach. And we decided that they did this because they wanted to have more focus on improving maintainability, flexibility, and the readability of code, while avoiding some common pitfalls and code smells. An example of a design principle that is aligned with composition is the SRP. It allows objects to delegate specific responsibilities to smaller components, leading to cleaner designs. Inheritance, by contrast, often results in classes that inherit behaviors that they don't fully need or understand. As for code smells, an example is refused bequest. Subclasses often inherit methods or properties they don't need, resulting in confusion and violating the principle of least surprise. Composition avoids this entirely by allowing objects to include only the specific behaviors they require. And a last example for code smells is large classes. Inheritance-based code can lead to bloated base classes as they try to accommodate various use cases and all their subclasses. Composition avoids this by breaking down behaviors into smaller and reusable components.
All right, so question four talks about working at a small seed startup, and because shipping features are prioritized over everything else, the code base is basically filled with objects with high coupling and low cohesion, and why it would be valuable to restructure the code. So right now, the current issue is that we have high coupling and low cohesion, which basically means that everything depends on everything. Like it's like very dependent, not very independent. And for example, like let's say we had a profile page, then changing it requires updating like the authentication, the database calls, the UI components, everything that can just like be copied over and over. And so what the solution that we can use is in the GRASS principle, which stands for General Responsibility Assignment Software Patterns, where we can do low coupling, which basically minimizes the dependency between these components, and we can use high cohesion, which keeps the related code together. And these changes enable independent features and reduces the cross system breaks. And so the way that the startup could maybe implement this is by spending about 20% of their time for cleanup and start with the most copied code that they can, refactor in order to do that. And then they can measure the time to implement new features, and they can track how long it takes. So the real impact of this is that, when they make a new feature, instead of taking, 1 week, they can reduce it to 2 days. Or any bug fixes, that may take like 5 or 10 hours, they can reduce it to 30 minutes. And, if they have a new dev, their onboarding is only takes like 3 weeks. It just goes to 1 week because they don't have a lot of code to show, and like it's like very repetitive, and it's structured. So yeah. And then question 5 talks about as a site reliability engineer at a growing tech company, and how there's a major incident in a microservice, and how this basically took several days to resolve. So the current issue is that, there's scattered logs across services, and this made recent incidents take days to solve. And so the way that we can solve this is using the observer pattern. And the observer pattern basically provides the solution, right? Because, services act as the publisher, and then the central logging service acts as a subscriber. And it's kind of similar to like a newsroom, right? Like the microservices are reporters, they're sending their stories or the logs to a central newsroom or a subscriber. And each service independently publishes logs without needing to know about the central logging system. Um, so it basically handles everything. So um, it's gonna handle storage, alerting, and dashboards. And when we need new logging features, we only update the central service. And yeah. And so some of the real world examples are like online store notifications. So the observer pattern is used here because it basically just updates all these microservices like one at a time. And it basically shows it like that. And then also similar to like how Netflix might track their analytics and check their viewer behavior across different services to generate recommendations. So by implementing this type of pattern, we can cut incident resolution time from days to hours and increase our system reliability.
All right, so question 6 talks about how a US-based company, financial institution, handles their payment logic, and it's very fragile because of its own unique processing pipeline. And we're tasked with refactoring the payment system by building a module that can generically handle a multitude of different payment types, such as credit card and PayPal. And one design pattern that can be followed is a strategy pattern. And this is useful because we have multiple ways to perform this task, and the need to switch between them dynamically allows us to use this. And since this task has each unique payment type, such as credit card and PayPal, it has like own unique processing pipeline. And this can be applied by creating a generic payment processor that delegates the payment processing to a set of interchangeable strategy classes. And each class will encapsulate the processing logic for a specific type, such as credit card, PayPal, and then payment strategy, like new payment, can be easily implemented by creating new concrete strategies without modifying the existing code. And 2 additional examples of using this pattern strategy can be seen in video games, where the game characters have different attack strategies depending on their weapons, and a character can use a sword a bow or a magic wand with each distinct attacking methods, and this character class serves as the context, while each weapon type implements attack strategy interface with with its unique attack behavior, and the game has like a dynamic change to the character's attack strategy based on the weapon. And another example is the travel route, where a navigation application such as like Google Maps can be offering like different routing strategies such as the fastest, the shortest route, or like the scenic route. And each strategy implements like a common interface like route strategy, which defined a method to calculate the route. And users can choose their preferred routing method, and the application can switch strategies accordingly.
So for question 7, we choose a mobile app we use regularly and describe its most prominent architectural style. So I chose to discuss about Discord. The most prominent architectural style of Discord is the client-server style. The reason being is the way the app operates. User interact with a client application that communicates with a centralized server infrastructure. So here's some reasons as to why the client-server style is a good choice for Discord. Discord relies on centralized servers to handle message routing, voice channels, and video streams. This ensures consistent performance, synchronization of data across devices, and ease of managing large communities. Real-time interactions, features like instant messaging, voice calls, and live video streaming require low latency communication, which is easier to achieve in a client-server model. The server acts as an intermediary that ensures all clients receive the correct updates in real time. Security and control. The centralized nature of client server allows Discord to implement robust security measures such as encryption, authentication, and moderation. The server acts as a single source of truth, simplifying data validation and control. Scalability. Discord is designed to support millions of simultaneous users across thousands of servers. The client-server model allows horizontal scaling of backend servers to handle this load efficiently, balancing user demand dynamically. Another architectural style used in Discord is event-driven style for smaller features such as notifications. Within Discord's larger client-server architecture, its notification system operates in an event-driven style. This system listens for specific events such as receiving a new message, someone joining a call, or a server update. These events trigger notifications pushed to clients in real time. Reasons as to why the event-driven style for notifications. Efficiency. Notifications are sent only when specific events occur, minimizing unnecessary processing. Asynchronous handling. Events are processed asynchronously, ensuring that real-time notifications do not block other operations. Scalability. Event-driven systems scale when the higher user activity, which aligns the Discord's dynamic and active user base. By combining the client-server model for its overachieving architecture and event-driven style for specific features, Discord achieves a balance of performance, reliability, and scalability. For question 8, we're explaining the purpose of testing stages, which are developer, alpha, and beta testing. So the purpose of developer testing is the first stage of testing conducted by software developers who build the feature. The goal is to catch and fix issues early during development, ensuring that features function as intended. Benefits are identifying functional bugs, which ensures the features allows students to submit and view anonymous feedback without errors. Code quality assurance verifies the edge cases. Unit testing, testing individual components. Integration testing confirms the feedback feature and how it helps. Developer testing ensures the foundational stability of the feature by catching major bugs before they reach end users. So alpha testing is conducted by internal team members or select users within the organization, such as quality assurance teams. The focus is on validating the feature works under real-world conditions and meets functional and non-functional requirements. The benefits is simulating real use cases. ensures that the feature performs as expected when used to provide and view anonymous feedback, checking user workflows, so it evaluates how students navigate the feature. Performance testing tests the feature under different loads. Security verification validates that anonymity is maintained and prevents feedback from being traced back to users. And lastly, beta testing. It involves releasing the feature to a limited group of end users outside the organization for feedback. This stage assesses how well the feature works in real-world educational setting with diverse users, benefits, user experience feedback, collects insight on how intuitive and effective the feature is for actual users, identifying areas for improvement in design and functionality, compatibility testing ensures the feature works across various devices, uncovering edge cases, real users often interact with the platform in unexpected ways, measuring satisfaction. So user satisfaction with the feature and its impact on their learning experience and how it helps ensures the feature is user-friendly and meets the needs of target audience.
All right, thank you so much.